We're looking at Glencoe Course 2 Math, Lesson 4-5 on adding and subtracting mixed numbers. There's two ways that we can do this. In our book in Example 1 and in Example 2, they show adding our fractions and adding our mixed numbers separately, where we have whole numbers adding with whole numbers, fractions adding with fractions, and we write the two next to each other to get to our answer. Now that works great if we don't have to borrow, if we don't have to carry in our answer. However, there's another way that we can do this that works every time. The way that we do that says that we get mad, we convert to improper fractions, and then we simplify at the end. When we do that, if our fractions add to be greater than 1, doesn't cause us any problems. If we are subtracting and we would need to borrow or regroup, that won't cause us any issues either. So when I solve the problems, I'm going to get mad because that way works every single time. When I get mad, that says that I multiply, then I add, then I divide. We multiply our denominator times our whole number. We add that value to our numerator, and we show that we're dividing by keeping the denominator the same. In Example 1, we are asked to add 7 4/9 to 10 2/9. When I get mad, I multiply the 9 times the 7, I add 4, and I divide by 9. 9 times 7 is 63, plus 4 is 67. And I show that I'm still going to divide that by 9. I'm going to add to that 10 2/9 as an improper fraction by getting mad, saying that I multiply, then I add, then I divide. 9 times 10 is 90, plus 2 is 92 over 9. I have a common denominator already, so what I'm going to do is add my numerators and keep my denominator. 67 plus 92 is 159, and our denominator of 9 stays the same. I don't want my answer in the form of an improper fraction. I need my answer as a mixed number. So I'm going to simplify. To simplify, I divide. My numerator goes inside the house, my denominator goes outside. 9 goes into 15 one time. 1 times 9 is 9. I subtract and I get 6. I bring down my 9. 9 goes into 69 7 times. 7 times 9 is 63. I subtract and get 6. That remainder of 6 becomes my new numerator, and I keep my denominator of 9. So this is equal to 17 6/9. I can simplify 6/9 by dividing both by 3. So that I get a total final answer of 17 2/3. What questions do you have?
What did you times both of them?
Yes.
After you multiply and add, so you multiply it, then you add it.
Mm-hmm.
And then you divide it after you get the other side.
Right, so the divide here, remember we said that a fraction bar was a fancy division problem? So we're showing my division problem, we're not going to actually divide. Because if we actually divided, we would end up with our mixed number again. Okay, but we can't just eliminate that 9. Alright? Any other questions? Yes?
Did you times 7 times 9 or?
Yes. What other questions do we have? Okay. Turn and look at example 3, please. Example 3, 2 1/3. Minus 1 2/3. Can I take 1 away from 2?
No.
I can't?
Yes, you can.
Can I take 1 away from 2?
Yes.
Can I take 2/3 away from 1/3?
Yes.
I can't?
No. I said no.
No, I can't do that. Okay? If we were going to do that by subtracting our fractions and then subtracting our whole numbers, I would have to regroup this 2 as a 1 and call that 3/3 and add those together so I'd have 1 4/3 minus 1 2/3. Guys, do we want to have to do that when we solve these problems? No. No. So we're not going to solve it like that. That's why I have us solve it this way. Okay? By doing it this way, if I have 2 1/3 minus 1 2/3, I have to get mad. So I multiply, then I add, then I divide. I multiply, then I add, then I divide. What is 3 times 2?
6.
Plus 1 is?
7.
Divide, and I divide that by?
2. 3.
3. And I'm going to subtract from that what's 3 times 1?
3.
Plus 1? Or plus 2? And I divide that by?
3.
Okay. What's 7 minus 5?
2.
2. What's my denominator?
3.
Then we're done. Questions? Both of these problems had common denominators already. Yes, ma'am.
My pencil house is this. And he think I'm afraid. He got it stuck on his
Questions about this?
Why do you have to put the divide sign here?
Because we have to show that we're still dividing by the 3. By using the fraction bar here, we're showing that we're dividing by 3. I want us to try one where we have to find a common denominator first. So, Miss Blum's example. We're going to use 2 1/4 plus 1 2/3. I need to find a common denominator. What is a common? You can find a common denominator before or after you find you convert to an improper fraction. Let's do it before this time. What's a common denominator between 4 and 3?
2.
Nope.
Oh. 3.
8.
I can't multiply something by 3 to get to 8.
6.
What could I multiply 4 by to get to 6?
12.
12 would be my common denominator. What do I multiply 4 by to get to 12?
3.
Times 3. we do it to the denominator, we have to do it to the numerator. What do I multiply 3 by to get to 12? What do I have to multiply the 2 by? 4 times 3 is 12. 3 times 1 is?
3.
So I have 2 and 3 12s plus. 3 times 4 is? 2 times 4 is? 1 and 8 12s. Now I need to get mad. 12 plus 2, or 12 times 2 is? 24. Plus 3 is? 27 over 12. Plus 12 times 1 is? Plus 8. 20. We divide that by?
12.
Okay. What is 27 plus 20?
27. Oh, 47.
47. We keep our denominator at 12. How do I get from 47 over 12?
Divide.
I divide. What number goes inside my house?
47.
What number goes outside? 12 goes into 47 how many times?
3.
3. What's 12 times 3?
36.
36. I subtract and get?
11.
11. What's my new numerator?
11.
11. What's my denominator?
12.
12. 3 and 11 12s. Would I have gotten that without doing anything else to 2 and 1/4 plus 1 and 2/3? No. It needed a couple steps. That's okay. What questions do we have? Thank you.